Right. Joel, how are you? So before we get started, just can you introduce yourself?
Yeah, so my name is Joel Ramos, and I am a software developer at Microsoft, and I just love everything UX and front end related. So here we are talking about web frameworks today.
Cool, cool. So, before we get too far to web frameworks, because you're a developer, I like to always ask this question. How did you get started? What was the first app you ever wrote?
Yeah, so I wouldn't call it like I guess it was a console app, right? But I picked up like an old textbook that one of my cousins had one random summer night or something. And I just picked it up and I followed the tutorial and I ended up with like a hello world type of application. And yeah, I guess the rest is history. So
When you say console, was it like a Windows console app or like a browser console app?
a terminal kind of based application. Yeah.
Cool. And what language was it written in?
Visual Basic, or it might have been like C sharp, I think actually. Yeah,
Cool.
C
Yeah,
sharp.
that's
Yeah.
awesome. That's a lot, and now you're doing web development or you're interested in web development and all of that. So
hmm
how long ago was that?
Since I started on web development or
Or
since I started
since you
programming.
built your first console app.
It was when I was a junior in high school, so about 7, 8 years ago.
Cool. Cool, cool, cool.
Yeah.
Nice. All right. So, now let's go and shift over to talking about web frameworks, and all the fun stuff there. So what do you want to start with?
So I recently started working on a team, right? And we're using React as our main framework. And it's React is something that I've been, learning by myself on the side, right? During college, after work. And one day I was going through this tutorial and the person giving the tutorial said two things that resonated with me a lot. And it was whenever you're learning a new tool, you kind of have to ask, what is the tool and why does it exist? Right. So I applied this concept to React, and I wanted to kind of explore why React exists and like why it's so popular, and also what problems does it solve, right? So why did the industry as a whole transition into using frameworks like React, Angular, Vue? How were web applications made before, right? That's like also an interesting question. And then also, where are we going to now? So that's kind of what was going through my mind when I reached out.
Wow, that's a lot of, interesting, topics to touch upon. So where should we
Mhm.
begin? Should we start with like why we have frameworks like React in the first place?
Yeah, sure.
Yeah, I think the way I like to start from is like the history of the web itself. When
Mhm.
when the web first came out, there really wasn't a whole lot beyond just I have text documents that are displayed on screen, and so
Mhm.
everything was so heavily optimized around that. So if you saw some of the earliest web pages like Tim Berners-Lee may have created, it was just some text on a white background, maybe an image here and there. Maybe there was no image at all. There were some links and so on, and so it was this document-centric model that the web was really built around. And as time went on, it really continued to go down that path where the kind of things that the internet was really known for was just text and large pages of text and things like that. It wasn't until JavaScript and Netscape and some of these things where the technology and the platform kind of evolved, where you could kind of go beyond just having static web content. You could have images, you could maybe even have videos. You had plugins like Real Player and Flash and things like that, which made the browser do a little bit more than what it could do before. And eventually to the point where you could kind of look at it and go, these apps I'm building, like these desktop applications or the console application, for example, I could maybe make it work easier in the browser where there is no installation, or if there's installation, it's like a plugin that everybody on the planet has, like the case with Flash, for example. And so we started seeing a trend where apps that have traditionally been like what we call thick client, like installable apps, started to be in the browser, in the web, and you could do more things through it, which also meant that the way you build for these apps kind of changed as well. The way you architect a large scale application, there's some common patterns. And the web, in many ways, wasn't really designed for that. With JavaScript, is single threaded. It had limited support in various cases for what you can pull off. Different browsers had different things, and ignoring mobile for a second. But if you had mobile in the mix, you had a whole set of things that need to be better as well. And you also had HTML, which had various levels of capabilities. CSS, which for a long time had a lot of things that a modern visual language often didn't support. Recently, it's gotten better, but over a period of time, was this evolution, which is really messy. There was a lot of things where, like, as a developer, you had to know what did Netscape support, what did Internet Explorer support, what did other browsers support, and so you kind of had to keep in your mind, like, can I use this capability? If I do, what is my fallback going to be, and so on. And so what really emerged was we need to get more things in the web that take the best practices of traditional programming languages and programming architectures, whether it's back end or front end. We need to do more in that evolution of space. And then the other part was, how do we just simplify it so that people can actually build with these applications in a way that if you're an individual, you can be successful, or if you're working in a team of developers, how do you make sure that some of these things scale as well? So a lot of things came around that point to figure out what are the best solutions here. And some have been more successful than others. Like today, we talk about jQuery quite a bit as having been one of the most successful solutions to kind of abstract away what a browser supports or doesn't support, at least from the JavaScript layer, and especially DOM manipulation, and be like, yeah, we will just write jQuery, and then it'll figure out whether it's going to use a native API, it's going to be a polyfill, and so on. And then as it evolved, you had various other frameworks, like MooTools was really big around, like, I have data that I need to somehow visualize in a very, in a more traditional declarative way, similar to how like XAML and WPF have like data binding support and so on. It's like, how do we take the best of traditional languages in terms of how do you solve common problems, which is I have data, I need to visualize it, it needs to be interactive. How can we simplify all that so a developer isn't spending all this time learning HTML, all this time learning CSS, and all this time learning JavaScript? And so we started seeing more richer frameworks that started to do really well. I'd say about probably 10 years ago, Angular was one of the big ones that really kind of highlighted that it is possible to build mission-critical line of business type of applications, which were very traditionally in the realm of traditional desktop apps. And it had like really rich templating, really nice models for being able to translate your ideas into code that was pretty universal across all the various browsers. So that was one of the first big frameworks in that sense. And then over a period of time, React kind of came into the picture as well, mostly because one of the big gaps that web apps often had was composability. I'm building some UI that needs to be replicated over all these various pages. It's one thing for it to be just something you can copy and paste and make it work, which you can always do. It's another thing for it to be a case where I'm building a component, I'm extending it with more capabilities, and I want to use traditional subclassing, classical inheritance kind of approaches that aren't just working on the code layer, but also work in the UI layer as well. And also, how do I think about UI development in a way where I'm not thinking about every state change as incremental stages and thinking about how I go from point A to point B, but how do I just think about in a case where I have my UI, it looks like this right now, here's what I want to look like in the end, and I don't care about how the in-between things happen. I want to make sure that you get a performant experience, but everything else is automatically handled for me. Those are really complicated problems, especially when thinking about performance and the tree of elements your browser needs to deal with and so on. And so React really came into the picture as solving that. And the use case for React was Facebook. Facebook, the timeline, the newsfeed, all these things have a lot of elements, and the way you build them is many of them are reusable components, many of them are composable through other components, and so on. How do we kind of standardize that and make the teams more efficient when building them? And React really gained a lot of popularity as being one of the first ones to not just solve the developer workflow problem where I'm thinking about UI in terms of actual UI, and I'm also representing it not in terms of a combination of HTML and JavaScript, but I'm using this newer syntax called JSX, which is kind of like a mixture of both. So what needs to be represented in markup can be in markup, but I can also put imperative code where I need to do some calculations of processing and so on. And there's a really nice templating mechanism where child components and parent components can transfer data back and forth. It had a really nice model that solved a lot of these things. And it also was just in many ways performant. It had the idea of the virtual DOM where instead of every operation traditionally taking like some operation where your screen needs to update, your tree needs to reflow, and like all these expensive things, the framework optimizes for the browser based on what is the least amount of painful activities we need to do to get a pixel to update on the screen in a really performant way. And so React touched upon the performance side of things and the developer experience side of things, which very few frameworks at the time really did a good job around. And of course, Facebook building heavily against it and also using it for their products gave it that validity that, it wasn't just a hobby, it was something that was actively maintained and could actually solve really big problems, because 99% of the time, what you're building is going to be far less complex than what Facebook has ever attempted to solve. And that really got us to where we are from the very beginning of this document-centric world to the world of today, where you have frameworks like React that kind of abstract away many details and then help you focus more on just building your UI, representing your UI in a more natural way, as opposed to figuring out all the edge cases, which historically you might have to deal with.
Right. So for folks that aren't like too familiar with React, right, there's the concepts of DOM and virtual DOM. And from my understanding, DOM, which is basically the structure for your web page, right? All the nodes and the whole layout is basically in this tree. And so traditionally before React, right, to do DOM manipulation, you would use just JavaScript. And then that evolved to a more standardized way with jQuery, right? And then jQuery had some optimizations for manipulating the DOM, which is really painful, right? Whenever you manipulate the DOM, does it cause an entire re-render of the page?
It depends on the kind of operation you're doing. Some operations, the browser's optimized heavily and it doesn't cause a re-render of the page, and some of them do. And there's a lot of URLs that kind of highlight like what CSS changes will cause a re-trigger and a reflow, what DOM activities will cause a re-render and a reflow. But in the most basic level, if you think of your DOM as just a tree of elements, if you're going to be adding or modifying something at a very leaf node at the very end, that's usually not too bad. You add an element or you remove an element from a leaf, it doesn't affect the rest of the tree. But if you're further up a branch, or even if you're at the root of the tree, if you were to make any modification there, it's going to have a ripple effect on every single thing out there. And our computers have gotten faster, our browsers have gotten faster, and even mobile devices have gotten faster. But if you look at the midpoint of like what kind of users will have the worst experience, you'll often think about, okay, if I'm on a tablet, if I'm on a low-powered mobile device, worldwide, that may not be the fastest devices that we might be using here. Then you have to think about, okay, then these approaches I'm using are not going to be great. And so even though our computers are getting faster, our web pages, of course, are also getting more complex as well. And so it's a constant chasing, a cat and mouse kind of a game, where our computers are faster, our web browsers are getting faster, but our devices may not be keeping up. And the kind of manipulation we'll be doing might just involve larger amount of elements. And so those are some of the things to kind of balance as part of how you're thinking about it.
Right. And so then transitioning to React, right, we have this idea of the virtual DOM, which in simple terms, it's the way that React is able to calculate the most minimal change it needs to do, right, to update the page, which you can obviously kind of see why that is an optimization, right? We don't need to re-render everything. We just need to kind of look at the virtual DOM, look at the DOM, compare them, what has changed, and go ahead and update that, right?
Exactly. And that's such a huge improvement, because oftentimes, let's say you have to make 5 DOM operations. If you do them sequentially, something might just be you're building something, tearing it down, building something, tearing it down unnecessarily. Versus if you kind of figure out, okay, here's my beginning, here's my end. How can I minimize some of this unnecessary, duplicative work where I'm just like doing work for the sake of doing it, because sequentially, that's how that may need to be done. You end up saving a lot of time by using a framework like React that has all the logic in place. And I'm oversimplifying it greatly, but it's a very complex kind of a diffing algorithm, where for simple trees that we can kind of visualize, like, yeah, I can see that this needs to be changed here and that needs to be changed here, and a diff makes sense. But we're talking about like, a page with like thousands of elements at any given time, where one part of a subtree, one part of the UI is going to be changing, other part of the UI is going to be changing as a result of something coming in from my server or some user interaction. The whole problem space gets really, really complex. And so, things like React have this lot of complexity, which I'm grateful they do, because otherwise you and I would probably need to figure out, how do we do this ourselves, or how do we make sure that we kind of, don't do it in a really bad way. But the one thing to also kind of add, as you might be seeing a lot of trends, these days, especially now, is that browsers have also gotten really good at optimizing DOM operations. So you often see the counter current, where a lot of people are saying React may not be necessary anymore for many, at least from the DOM performance point of view, because the overhead of the virtual DOM of this work is already being replicated by the browsers natively. So that might be, it may not be giving you that much benefit, at least from the performance point of view. The developer experience point of view, of course, that is still very much that really can't be changed. It's a good thing that React still has JSX and the large ecosystem that is built up around it, including meta frameworks like Next.js that go one level beyond what React provides. But the performance angle is one where I think it was a big thing like 4 or 5 years ago. Maybe the jury's out right now on do we still need those at this very moment today?
Yeah, so that kind of leads into my next question of okay, so we've been talking about how React is so great, how it's been in many aspects revolutionary. What are some of its shortcomings, and why has there been enhancements like Next.js and things like that?
Yeah, I'd say there are multiple ways of thinking about where React comes in, which is also similar to how jQuery has evolved from being you must use it to being well, your browser kind of does a lot of these things for you automatically. And so I think we touched upon a performance angle where if you're building using JavaScript APIs and you have more capabilities in the DOM and in CSS for being able to arrange data and virtualization and things like that, you kind of get some benefits that React you may not need. An example recently is that I had to build a grid of emojis that had 2,000 or so icons that would be displayed on the page. And by default, if I did not use something like React, it would take a long time to create all those elements and load it. I could use a virtualization library where it only rendered what I need to use on screen, but those are complex and it requires a dependency on something else. But now the browsers support this whole idea of being able to lazy load images only when they hit the viewport. So you can actually specify the loading attribute to be lazy, in which case now a 2,000 element emoji images being displayed takes a fraction of a second, if even that, because it only renders what I need to, and it's provided natively by the browser. And so an area where I normally may have used React because it handles some of these things for me, I'm now able to save 30 kilobyte, 40 kilobyte, or even 100 kilobyte JavaScript bundle that gets downloaded, because that's one of the bigger things about frameworks in general that people often, and I personally, have some, issues with, is that there's a large size on, download. You're downloading a large amount of JavaScript, and your browser also parses the JavaScript every single time. So it's not just a download size, it's a CPU's amount. And then on a battery device, these things add up. And we've always seen those statistics that show your average web page is now bigger than interactive video games from 10, 11, 12 years ago. Your typical web page is 10 megabytes, 20 megabytes, 30. It's unbounded in how large things go. And so there's this movement, or at least I like to think there's a movement where we're trying to okay, let's kind of not add more bloat to a web page. Let's try to scale it back down where it makes a lot of sense. And so you have React, and you have newer versions like Vue, Vue.js is in a version where it's yeah, we'll take the best parts of React, make it even more lightweight. And then you have Preact, which is in many ways like React, takes a React syntax, but cuts away a lot of things that are going on. So you're seeing a lot of this innovation and interesting work from the community in general on how to address various parts of these shortcomings. But what ultimately React and even Vue solve for is a single page problem. Is that I have components and I have a single page, and I want to be able to make sure that it renders appropriately. Now, realistically, most of the stuff that we build is multiple pages in size. You have I might have let's say, let's take a restaurant, for example. I might have multiple pages here where I'm going to be having page A, page B, page C, and page D. How do I make it work in a more traditional world where I don't want to load everything at once when I'm loading my page at the first time? I want to be able to kind of have this natural web-like world where I'm going to navigate from page A to page B. There might be a transition. There might be some state might change, others may not. These multi-page applications, which we kind of took for granted as just a traditional web thing, never really quite caught up to how you might build these kind of apps in a more modern kind of a environment. And so that's where frameworks, or what they call those meta frameworks, like Next.js and Next kind of come in, where it's okay, let's take the great ideas you have for building single-page apps, now extend that for multi-page apps as well, where you might want to go for server-side rendering, or or ISR, or static site generation. All these various things that really optimize heavily for, I'm still building my application as this one monolithic, large kind of an activity, but I'm going to be, what the end user will see, though, will be one where only what they need will be what gets downloaded and used, which is really just exactly the kind of thing that you're going for.
That's really interesting to hear. I never really thought about like, what if we did want to have that like native browser feel of navigating from page A to page B to page C. And when we're talking about a site that has thousands of pages, like, do we really want to be loading all of them in at once, right? Is that the best way to do that? So I'll definitely have to check out like Next.js. Like I said, I'm just kind of exploring this framework world, and I think that asking the question of why is React a thing, and what problems does it solve, and also its limitations, naturally creates this world for exploration and innovation, and what is Next.js and how can I make React better. So it's very interesting to hear like that perspective as well.
Yep, and in parallel, of course, the browsers again are still doing really good work. So, for example, if I want to create a single-page app that has the performance of a multi-page app where things are being downloaded on demand, but the user experience is one where a transition from one page to another or from one view to another feels very native-like, where I'm animating like a page from one to another, as opposed to just being like a hard reload where the entire page gets torn down, a new page comes in. There's new ideas called the web transitions or page transitions API, which is being introduced, where you can actually do that without having to rely on any third-party frameworks. So we're seeing this really nice mixture between all of this. Now, the doorbell's ringing. Give me 1 second.
Yeah, no worries.
All right. Well, good thing there's always editing, so I can always edit things out. So where were we? Oh yeah, that's on the page transitions API. Yeah.
Yeah, so actually, I think I was reading about that a couple of weeks ago, and that was kind of a really interesting question of like, I can't believe that hasn't already been introduced into the web world, right? It just seems like something that would already be there or should be there. So that's also exciting.
It does exist, and it had existed in various phases. Actually, when I was actually, I think Jake Archibald, tweeted out about this about a month or so ago, I replied back and put a screenshot of Front Page 98 from 1998, where they actually had an ability for use JavaScript to create all these transitions like blinds and checkerboard and so on between pages. So the technology had always existed, but the question always is like, how can we make it work without adding more bloat, adding more capabilities? And in reality, you're kind of offsetting some of that by making your browsers be a little bit larger because you have more capabilities in it. But it's kind of a case where you install the browser once, and now you have all of this for free. So it's kind of like amortizing the cost, its performance, to the browser now having it as opposed to the framework. So there's a lot of interesting things that we kind of have to kind of play back as well in terms of like, okay, why did it not succeed back then? Why do we make it work better at this time? And how do we make it work in a way that works on mobile devices, multiple rendering engines and platforms? How do we make it work in a performant way? So if you, for example, you may not want to have a transition in place. You might then have like, let's say it's an animation, and you have your system settings set to say reduce animation for accessibility reasons or personal preference. You respect all that. So the complications of building software, or especially browser capabilities, just also increases linearly with like number of devices and capabilities as well.
Yeah, there's definitely a lot to consider when like developing a browser that's supposed to render everything correctly in every device possible. So I mean, for me, like, that's the exciting challenge of web development, to be honest, and that's what I enjoy doing.
Yeah,
it's like exactly. A puzzle, basically.
Yep, and I'm still like a big fan of just traditional HTML, CSS, and JavaScript. So for me, like, no matter how much React and like all these frameworks are doing, like, I love all the stuff they're doing, but how can we make the web just better in general so that we don't have to have every developer out there take this? Because when you do look at the size of like all these frameworks, they do add up. By default, a Hello World app in some of these languages is like 300 kilobytes, and I'm like, there's something wrong here. And so, but it's just me though, because at the end of the day, if I had like a team of developers, or I'm working in an organization where there's an existing code base that's like millions of lines of code built in a particular language, those things I think might kind of shift the balance towards, let's use a framework, let's simplify things. And if you imagine a world like TypeScript was one of those examples where before TypeScript, JavaScript was not the best choice for large-scale applications, because accidental errors could be introduced, and it's very difficult to pinpoint where they might be. And then TypeScript simplified a lot of that greatly. And so I think it's going to be a case where how do you make sure developers are productive without negatively impacting the end user's performance and those goals? And I think those are the things that are always at odds with each other, but I'm hoping that one day there might be a solution that kind of aligns them both. So what's good for developers, and it's also good for users as well. I think frameworks are, I think it's still over optimized for developer productivity, less so over what an end user might see.
Right, and I think you hit it right on the dot, right? Like, and that was why I wanted to have this conversation, was the use case for React. Why use React? When to use React? What are its limitations, right? And I urge everyone like listening to just think about that for every tool that they use, right? One of my other questions that we might chat about later is why JavaScript? There seems so many complications with it being single-threaded. Why has there not been anything that's been introduced, right? So yeah, just always challenge everything.
It's one of those things also where when we look at like web and like why people build web apps, it was always like, okay, so lowest common denominator is the fastest way to get to the largest audience. Almost every device on the planet can run a web app. And then once you get to the point where like, okay, I'm seeing a lot of traction on mobile. Like we have a good product, the feature set is good. Now I'm going to build a native application. And when you go native application, you have multiple options here as well. Are you building a native application because you want better device access? Then you have tools like that wrap a browser in a native container, like your typical web view components you might have for Android or iOS, or abstractions of it like PhoneGap Cordova or React Native. And then you also have nowadays the best of multiple worlds where you're not really using web technologies at all, but you're using something that is still a write code once and have it work really quickly across all these platforms. In the case of Flutter, which is you're writing in Dart, but then you're compiling natively into the UI language of every platform you're targeting. So you get like both code reuse and really great performance, something which you couldn't get with the WebView solutions because you're always limited by the single-threaded nature of JavaScript and then translating between JavaScript and whatever native language you needed to build, like native UI and so on. And so that kind of solves some of those gaps. And then, of course, ultimately you have the ideal end solution, which is like the most amount of time, which is I'm going to build natively for every platform very uniquely for it, which means I'm learning all the details of iOS development and using Swift and Xcode and Objective-C and everything about Android development, Java, Kotlin, and all these other things. So it all depends on like how, productivity, again, like how much time do you want to spend in building a solution and to what the final end experience will be. And oftentimes there is no good, answer. Oftentimes you find that line of business, traditional enterprise apps, they tend to optimize more for being able to be agile, be able to get something out the door quicker in users, and less so on user experience. Whereas with consumer apps, you often have the opposite, challenges. Like with consumer apps, you want to make sure the user experience is very, very polished, even if it means that we have large teams doing work uniquely for every platform. And the web, in many ways, still happens to have that lowest common denominator sticker associated with it because the web is not often the fastest of the various solutions you might have there. And different platforms prioritize web differently. We know that some platforms like Android are very open to web and provide really good integration between the device and web itself. On iOS, the web is still oftentimes in many ways competing with the native app stores and native apps available in terms of what is and isn't capable. So there's some things you need to kind of keep in mind there. And of course, desktop, it's a free for all. You can do whatever you want. And you have like Electron apps, which are like really popular as well, where you're using the web runtime in a desktop context. And so I don't see the web ever slowing down in terms of being this right tool, but you often do also see that the convenience of the web might not be the best thing when people often look at, like you say, like, oh, my VS Code or my Slack or my Teams app is taking like hundreds and hundreds of megabytes for basically displaying some text on screen. Would that be the same thing if these apps are built natively using native platform capabilities and APIs? Maybe. We also know a lot of native apps that don't exactly do really well on the performance side, but the opportunity for doing better exists, whereas with the web, you can only go so far because you are adding multiple layers of abstraction. We have your native hardware, native operating system capabilities, then you have your web rendering runtime and all these layers on top, which a native platform may not always require. And so, but again, many computers have a lot of RAM these days. And, despite that, our computers still feel slow. And so you kind of go back and go, is the web helping or hurting, and so on. But it's all fun though. Like I keep seeing this. There's a pendulum keeps swinging back and forth on like all web versus all native to all web again. So right now we're in the web phase.
Yeah, and ideally you'd want just like to give the user the native experience every time, right? And it's very hard to accomplish this, right? And you see it with web development with like PWAs, right?
Yeah.
That is something that I recently started looking into, but it's really cool that this basically website can be taken offline, can be downloaded, and because it's a PWA and you specify these things, you can like add it to your taskbar in Windows and things like that, right? So ultimately, we want to provide the user the best experience possible, and it's just interesting to see all the different solutions that can try and aid that challenge, right?
Exactly. And I'm probably gonna be dating myself heavily by explaining this side of it, but the idea of like write code once and deploy to everywhere has been around for a very long time. I think Java was one of the more popular solutions where you could write a Java application that ran across all these things. And early on, it looked exactly like a Java app. You could see a Java app from a mile away because of, it had like the little purplish gray color, the buttons, everything was the same, and so on. And then like eventually like different UI toolkits like, I think it was like SWT or I forget what it's called, but like that kind of came in where it's like, yeah, you're defining a button in your code, but the button would look like a native button on Windows, a native button on Mac OS, a native button on Linux. So it kind of gave you that familiarity of like, oh yeah, I can see my apps looking and behaving appropriately, right? And people typically like that. And with the web, we kind of went back to the old legacy world of like Swing and more traditional Java development, where it's extremely difficult to build UI that adapts to to the native UI look and feel the platform you're on. I think like Ionic and some of the frameworks and toolkits do a good job there. But ultimately, what you end up doing is taking a bet on a design system like Material Design or even Fluent, and just going like, okay, I'm just going to optimize for the material look and feel or the Fluent look and feel, and that way everyone has a very consistent experience. But that consistency may not match native look and feel. And when you do try to add native UI, which you can do with like Flutter or even like React Native, now you're having like two code bases in some ways. Where like, okay, my list view is very different on iOS than it is on Android. It's not even a case where this looks different. The interactions are very different. So you need to have like specialized code in all these areas. And so you kind of like, the intentions are good. I want to write code. I want to build the right UI for my audience. But then as you get deeper into it, the more you go into, I want to optimize for my own productivity, the user experience suffers. Or when you go into the point of like, I want to really optimize for user experience, your productivity suffers because now you're like going back into writing multiple lines of code, multiple variations of code and languages and so on. And so I call it job security though. If it's all solved, it would just be a case where I'm like going to some AI ML solutions going like build my app, foo, and then it just spits out an app that does everything it wants. It being complicated does give us a certain level of like, yeah, we still need human beings involved in some of these cases. But the other angle is, of course, maybe there are more creative, more advanced things all of us as humans could be doing than writing a button over and over and over again to make sure that alt text displays when you're hovering over it. So, like just it's complicated.
It is very complicated.
But yeah, is there anything else, that you want to touch upon?
I know we don't have much time left, and I mean, I have thousands of questions, but I think for now, I think it's a good stopping point. I think we covered like a good amount of, the before, during, and after, or I guess future of React and where that's going. And so you definitely gave me some, starting points. I want to look at Next.js. I want to look at web transitions, or just like also what optimizations are browsers doing, what's CSS doing in terms of development, and can there be any more enhancements for HTML, right? So there's just a lot to look into. So
cool. Well, Joel, it's great chatting with you about all these topics, and we should probably do this again sometime.
Yeah, sounds good.
Cool. All right. Talk to you in a bit.
Yeah, thank you, Kerbo.